All right, here are solutions to our seventh written problem from Math 243. The basic idea here is we're looking at concerts in California and Oregon. I suspect that in California they're more expensive. To test my claim, I randomly select 10 artists and track the cost of their concerts in each state. So note that it's the same 10 artists. All right, here's some artist, and that artist charged $19 in California and $20 in Oregon. The fact that it's the same artist tells us that this is dependent data, and that's really important that we have this matched pairs design. That tells us that we don't really care about the California or the Oregon. We really care about the differences. Maybe Cali minus Oregon. So 19 minus 20 gives me -1. 20 minus 15 gives me 5. 20 minus 10 is 10. 22 minus 15 is 7. 2, 7, 0. -10, +10, and 16. These represent how much more expensive it is in California than Oregon. So in this case, that's negative. It's actually less expensive in California than Oregon. And what we're supposed to do is hypothesis testing and then confidence intervals on this data. So I guess first thing we might want to do is enter this data into a list. And so the idea here is if you go stat and then edit, you could just type in the data, the differences in a list. But rather than do that, I think what I'm going to do is I'm going to type in the California data in L1 and then the Oregon data in L2. And then I'll make L3 find the difference between those two. And the reason I'm going to do that is because I know, since I wrote this problem, that later on in part 3, you're going to have to redo this, assuming that it's independent data down here in part 3. So eventually, independent, we will need to know the California and the Oregon, not just the differences between the two. So that's what I'm going to do now. Now that I have all this data in L1 and L2, what I'm going to do is program L3 to take the differences of those two. So I'm going to go up so that L3 itself is highlighted, not the first observation in L3. Then I'm going to say I want L3 to be L1, so second and then 1, minus L2, so second and then 2. And then when I hit enter, it'll populate this list, and that'll serve as a good check. -1, 5, 10, 7, 2, 7, 0. Hopefully I'll see a -10, a +10, and a 16. I do. So good, it looks like I entered all my data incorrectly. Correctly, not incorrectly. Anyways, what I'm supposed to do is hypothesis testing. So first state the null and alternative hypotheses. Sure. So here's number 1 here. The key word here, let's see where the claim is. I suspect that concerts in California are more expensive. So more expensive would correspond with positive numbers here. So what that's telling me is that my alternative hypothesis is that the mu of the differences would be greater than 0. Greater than, because positive numbers mean California is more expensive than Oregon. And my null hypothesis is, nah, it's the same. There's no difference. Mu of the differences just equals 0. Because I put a greater than sign here, it is a right-tailed test. It's worth pointing out that you could do Oregon minus California, in which case the sign would switch on each of these. It would be a less than sign and it would be a left-tailed test. So different ways you can do this that would be completely correct. I just think this is the most logical way to do it. Second is we have to sketch the picture. You don't worry about shape, center, and spread. So here's my picture. As I always do, I'll put 0 in the middle. And then I need to calculate my test statistic and my p-value. Both of those will come straight out of my calculator. Stat and then tests. And because I have dependent data, these differences make sense. So essentially I've turned 2 lists into a single list. I don't need 2 sample t-tests. I just need a t-test because I really am only testing one list, the differences. So I select t-test here and then tell it I have the data itself. The data is in L3. That's where I put the differences. My claim is that the differences are greater than 0. Note that mu naught is 0 here. That's this 0 here. And then I can either calculate or draw. You should probably know at this point I typically draw when I'm doing the p-value method. So it's going to slowly draw me my picture, and it's going to shade in. There's my test statistic. Indicate it with a t. T equals 2 point something, 0078. And the p-value, because it's a right-tailed test, is the area to the right of that test statistic. In this case, that area is 3.78%. So what's that tell you? Well, if you go up here, we want 95% certainty. So that's telling me that alpha is 5%. If alpha is 5% and my p-value is 3-ish percent, it tells me my p-value is less than alpha. So when I state my conclusion, I'd say something like, because the p-value is less than alpha, there is sufficient evidence to reject the null hypothesis. So I can conclude that concerts in California are more expensive. All right, and I guess that was 1A, 1B, and 1C, so I'll relabel that. Question 2, same idea, except now it's a confidence interval instead of hypothesis testing. We want a 99% confidence interval for how much more expensive the concerts are in California, and we're doing the picture and interpreting the answer. So sure. What we'll do for this one is instead of going to test and selecting t-test, we'll select t-interval because it's a confidence interval. And then you want to tell your calculator to get the data itself as opposed to statistics about the data. And that data is still in L3. And the level of confidence I want is 99%. So I can calculate that value. I'll sketch the picture, something that's approximately normal. And what I want to include is, does it say it here? Doesn't say it here, but what I want you to include is your level of confidence. This is 99% certainty. Your point estimate, the point that's in the middle, and the bounds of your interval. So the point that's in the middle is this x bar here, the 4.6. The bounds of my interval are negative 2.846 and positive 12.046. So for my conclusion, I am 99% sure or confident that concerts in California are between this much less expensive and this much more expensive. Less expensive because you see this negative sign here. So I don't know, maybe it would make sense to round to the nearest penny. I could say $2.85 less expensive and $12.05 more expensive. So something like that. Doesn't need to be that verbatim. I should probably change color. These are going to blend into each other pretty easily. What we're supposed to do in 3 here is recognize that we're changing things. We just want to redraw the pictures from 1 and 2 above. So redraw this picture and this picture. You don't have to do all the other steps. But the big assumption is now the 10 artists were randomly selected for the California sample, and then I randomly selected 10 more for the Oregon sample. So there's no connection between the two. I have independent data. And so what that will change is instead of using a t-test function in my calculator to get this picture, what I'm going to do is use a to-sample t-test function to get my picture. So to-sample t-test. And it'll ask me which 2 lists I want my samples to be. Well, I want them to be L1 and L2 as opposed to the differences L3. So I'll put in L1 and L2 here. And again, my claim was that L1, which is California, is more expensive than Oregon. I always put no for pooled because I have no reason to believe that the standard deviation of the costs are the same in the 2 states. Always no in this class. And then I'll go and draw here. And it's going to draw my picture for me, and I got to make sure I include the test statistic and the p-value. So my test statistic was 0.5 something this time. T equals 0.5819. And I have this fairly large p-value of 28.4%. And I think that's sufficient for redrawing the hypothesis testing picture. Now I'm going to redraw the confidence interval picture, and then I will be done with this problem. So I'm again doing my best to draw a normal distribution. They don't always look that pretty. And I want a 99% confidence interval still. But what's different is instead of selecting t-interval, I want to select to-sample t-interval. So stat tests, and then let's find to-sample t-interval. It's way down here somewhere. Hit enter. Again, it's L1 and L2. I want 99% confidence. I don't want to pool, and I'll calculate. It's going to spit out 2 numbers, the bounds of my interval. So negative 1817 and positive, this is rounded to 2 decimal places, so maybe I'll call that 2737. And then, not the end of the world if you forget to do it, but ideally we should have the point estimate like we did up here. It's going to end up being the same point estimate, 4.6. You can get that by doing 33.6 minus 29, and you'll get this 4.6, which is our point estimate. And those are the 2 pictures redrawn under the assumption that we have independent data. I guess that's the end of this problem.